Summation to integral calculus. Okay, very difficult discussion we have taken. Summation to integral calculus. How I can divide my problem. How I can divide my problem into n number of parts and then solve part by part. How to divide problem into n number of parts, then solve the problem part by part and then finally assemble it. Once you assemble it, then you can think about making n tends to infinity as per the requirement. If n tends to infinity as per the requirement, if we are able, if I need to change it to infinity, then it will come to integral calculus. Many discussion we have taken that how we can make an approach to convert the summation into integral calculus. What is integral calculus? What is summation? That we have to understand to its depth. Then only we can convert the repeated summation into integral calculus. Okay, that is the scenario. Okay, so where we are in the vector terminology. First is that we divide our problem into n different parts. First concept is to divide the problem into n different parts. That is the first concept. Second concept is that find your solution for each part and then assemble it. Okay, so we have taken example like if this is a circle, then this is x-axis. If this is x-axis, this is origin. Then this is y-axis. If this is x-axis, then this is y-axis. Now I have to find circumference of a circle. Circumference of a circle means length of any curve. This can be like this also. What is length of this line when this is x-axis? Length of this line. Length of a curve that forms a circular equation, x square plus y square equal to a square. X equal to y equal to square root of a square minus x square. If it is a line, then it is y equal to dy by dx into x. I mean y equal to mx. It can be y equal to x, y equal to 2x, y equal to 3x, y equal to 4x, like that. Or I can have altogether a different curve at all. What is this? This is parabola. This is a parabola. Parabola, this is origin. This is origin. Hope. This is y. Oh, this is x-axis and this is y-axis. This is parabola equation y equal to x square or y equal to alpha x square whatsoever. Or this is equation of a line. This is equation of a line y equal to x square. Y equal to, I believe this is perfectly all right. Y equal to x square. Okay, or y equal to ex, y equal to exponential of x, or y equal to 1 minus ex, it will tend to 0. 1 minus, it will go like this, 1 minus ex whatsoever. What is the length of the curve? That is under question mark. What is length of the curve? If I say I have a parabola, then I have x-axis. This is x-axis. This is origin. This is x-axis. Now I want to find the length of this parabola between x equal to minus 1 to x equal to 1, where equation of parabola is y equal to x square. Make sense? Y equal to x square, the equation of parabola. I want, if this is x equal to 1 and this is x equal to minus 1, it goes up and hit here. From here, it goes up and it hit here. Now, this is the length. I want to calculate the length. I chop this between x equal to 1 to x equal to minus 1 into n different parts. For any particular ith part, this is first part, this is second part, this is ith part, I go up and find the length of the ith part. If I find the length of the ith part, consider this is pi, parameter pi. Then what is the length between these two? Summation I equal to 1 to n, because we have divided our x-axis. Mind it, I have not divided this into n part. I have divided x-axis into n part between -1 to 1. If that is the case, then we have summation sigma sign summation I equal to 1 to n, length of the ith section. What is the length of the ith section? That I don't know, but whatsoever. This is a generic algorithm that I can write in the notebook. Okay. Now there are many ways to calculate the length of the ith section. If this is up, 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 up. If this is the ith section, it go and hit here. What is length of the ith section? Then add for all the section whatever it maps on the parabola. Add all, you get the length of the parabola. Okay, for simplicity, we will take the length of the circle. Circle is nothing but it's a simple y equal to fx. Y equal to fx, that is a function and that is the circular function. It can be anything. We showed so many things. Now concept is, what if this is x-axis and I have chopped into n different parts. Consider this is ith section. It goes and maps here. Okay, this is one point, this is another point. This point is x1, y1 and this point is x2, y2. In that fashion, this if I connect origin, this is origin to x1, y1, there is a vector called p1 and there is a vector called p2. p1 is x1i plus x2j and p2 is x2i plus y2j. If I do the subtraction, then p2 minus p1 or p1 minus p2, it will connect x1, y1 and x2, y2. This will be another vector. If I calculate the magnitude of this vector, more or less, I'll get the length of this section. But it will be a straight line I am getting, where the idea is to get the curve line. Now I can rewrite summation I equal to 1 to n and length of or magnitude of delta p of the that belongs to ith section. If this is the ith section, then it go and touch here. When it touch here, then what is the delta p, that is p1 minus p2? What is the magnitude of this? Delta pi magnitude. If I add, I get the length of the parameter provided n tends to infinity. If n tends to infinity, this will be tends to 0 and then this delta p length of the vector will be same as the arc. Okay, that is the one concept. We are trying to bring in one thing that is concrete is what is the length of a curve. Take ith section on the x-axis, go and map it on the curve. Whatever the length of the curve of the ith section, if I add it for all I between 1 to n, I get the length of the curvature. That is for sure. Summation I equal to 1 to n and length of the ith section. Now here, if I take vector terminology to calculate the length of the ith section, then it is the length of a straight line vector, which is not perfect solution. It can be perfect if n tends to infinity. Then we can say summation of I equal to 1 to n tends to infinity, length of ith section. Okay, where length of ith section is delta p or difference of the position vector of the ith section, which is a straight line. And if n tends to infinity, then idea is that it should give the perfect. What is the another technology that calculates n tends to infinity? Because summation cannot calculate n tends to infinity, not possible. There is a ready-made technology which calculates n tends to infinity, and its name is integral calculus. Okay, someone has to transform this summation to integral calculus. By default, it does n tends to infinity. That is available. In means inherent nature of integral calculus is to add n area subsection. Integral calculus calculate the area. If there are n number of area, if I'm calculating an area, if this is the function over x, and this is x-axis. Then this is y-axis or function over x-axis. If this is function over x, then if I do fx dx, then it calculates the area underneath between x1 and x2. This much area underneath it will calculate. I can represent this fx dx limit x1 to x2 same as a summation sign. Summation sign I equal to 1 to n fx delta x I of the ith section. If I divide between x1 and x2 into n different parts, I take any ith part, and if I multiply height, that is fxi, into delta x, then it will more or less it will give the area of this subsection. If I say n tends to infinity, because area of this subsection is actually, if you see the vertical point, it is a curvature and base point is a flat line. If I say fx into delta xi, it will give the area of a rectangle, not the curvature part. If n tends to 0, n tends to infinity, or this section tends to 0, more or less it will be equal. So the integration is an inherent nature of calculating the summation of n different subsection of area, not the vertical. Area. Area strip, if I take an area strip and then I have so many area strips and they are in n in number where n tends to infinity, then I can say summation I equal to 1 to n tends to infinity fxi function over x in the ith section, that is the height, into delta xi. If this is the case, it can be directly transformed into fx dx limit x1 to x2 directly, because that is the inherent breakup of this integration into the summation. Anyway, now we are in phase of using vector to calculate the ith section length. One vector we use right now, that is delta p. If I have a delta p and magnitude of the ith section, if I sum it for all the n section, n tends to infinity, I get the length of the curve. What is the another methodology that we are using to calculate it? Then we use something called tangent. A new technology came that is called tangent. What is tangent? Tangent means if I have a curve line, everywhere curve line direction is different. If I see a curve line at this point is x1 comma y1. This is x-axis. This is y-axis. It begins at origin. This is y-axis. This is x-axis. This point is x1 comma y1, x2 comma y2, x3 comma y3. At this point, the direction of line, if someone see, it is going like this. At this point, the line is going like this. At this point, line is going like this. At any point x comma y, what is the direction of the line? Okay, or if I say this is the line that is passing x1 comma y1, then what is the equation of the line that we saw? That is dy by dx. Y equal to dy by dx at a particular point where I want to calculate the equation of the line. If this is x-axis, there is a point here called x1. It goes and hit here, and this is a point called x1 comma y1. If this is x1 comma y1, then at this point line is passing like this. Okay, what is the equation of line that is passing like this? If this is x2 y2, then line is passing like this. That is the direction of the line at point x2 comma y2. This line is changing everywhere. It is changing the direction. At x1 y1, if I try to find the equation of line that is actually this curve line represent a straight line at that point, is y equal to dy by dx at x equal to x1 into x. That is the equation of the straight line. That is also called tangent. If this is x-axis and this is the line, then every point tangent is along the line only. Tangent is along the line only. Because every point, if I say the line direction, it is exactly in the same direction. But for curve, every moment line direction is different. So we talk about the line equation. If I have a line equation that is y equal to dy by dx into x, what it says? If I'm trying to find line equation at any point x comma y, I take a delta x, very small x-axis interception, and I take delta y. What is delta y by delta x? Makes sense? I believe it is all right. If there is a point called x comma y, place that point on x-axis. If I intercept that point on x-axis, if I intercept that point on x-axis, it comes here. This is x and this height is y. This is x and this height is y. Now from x, I take a small distance called delta x. This is delta x. Or someone can take from x, delta x minus delta x by 2 left side and delta x by 2 right side. Then width is delta x whatsoever. At x, let's say I take delta x width. Now if I go and hit this, then it come like this. This height where it hits the next point, this is x and this is x plus delta x. If it go up and hit this point is x comma y, then this point is x plus delta x comma y plus delta y. More or less, if I see this small subsection which I am considering as a straight line, then there is a vertical component called delta y and there is a horizontal component called delta x. If I know delta y by delta x, then tangent equation, what if this is a tangent at this point, if I take this tangent and hit x-axis, then it forms an angle theta. What is tan theta? Tan theta is delta y by delta x, not this y by this x. Whatever delta y and delta x we are talking, that is delta y by delta x tan theta. That is the nature of the line. That is y equal to delta y by delta x into x is the equation of the tangent line. Okay, what is delta y by delta x? Means per unit x, per unit, 1 unit. If I said, if I say how many is the y when on x axis it is delta x, then it is delta y. How many in y I see when in x axis it is 1, then it is delta y by delta x. Means if this line, if I want to convert into vector, then it will pass through point origin, then it will pass through. Now this was a tangent line. Now I take it parallel line because vector is like that. Now if this is origin, then another point through which this tangent line is passing is 1 and height is dy by dx. Means vector equation of a tangent line is I plus dy by dxj. If this point is 1 comma dy by dx and this is origin, then vector equation of the tangent line is I 1 into I plus dy by dx into j, that is the y component. Means if I have any curve and this is the position vector along the curve, this is the position vector along the curve. This point is x comma y. This is origin. This is the position vector of the point x comma y. Then if I say this is the tangent line, that is y equal to dy by dx into x at any point x or any point x1, then if I want to represent as a vector, then that is I plus dy by dxj, and this point is x comma y, then position vector is xi plus yj. So if position vector is xi plus yj, then tangent vector is I plus dy by dxj. Looks like tangent vector is derivative of position vector. I take any curve, any curve. If this is the curve, that is y equal to x square. This is the curve equation, y equal to x square. This point is x comma y. This is the position vector connecting x comma y to x. This point is xi plus x square j. Then what is the vector equation of the tangent line that is passing through this point? That is I plus dy by dxj. That is I plus 2xj. Okay, if I watch closely, oh, what is that? My position vector was xi plus yj. If I take derivative of position vector, it becomes I plus dy by dxj. It is same as what we are saying tangent line. Means at any point on the curve, if I try to calculate the tangent line, then it is derivative of the vector. Now let's go back to our original problem. The concept is we don't want approximation. We tried calculating the ith section. This is x-axis. Okay, this is x-axis, and we chopped x-axis into n different parts. This is the ith. This is the first section. If I say this is the ith section, or if this is origin, if this is the origin, then if I say this is the first section, say whatsoever. If this is the ith section, it go and hit here. If it hits here, if this is the ith section, it hits here. Then this is the curve of the ith section. If I divide x-axis into n different parts, and then I write what is the length of this curve, only half of the curve length I can calculate now. Then summation I equal to 1 to n length of the ith section. What is the length of the ith section? This is the ith section on x-axis. If it goes up, the length of the ith axis, is Li, Li or Pi, parameter I. Summation I equal to 1 to n parameter of the ith section. What is the parameter of the ith section that we are trying to calculate? If I take any point as x comma y, I take any point as x comma y, any point x comma y. At this point, what is the tangent equation at this point? Tangent line. Then it is y equal to, if I take any point here alpha comma beta, any point alpha comma beta, what is the tangential line equation at alpha comma beta? This is the tangential line. What is this equation? Y equal to dy by dx at x equal to alpha into x. Make sense? Okay. Tell me what is the equation of tangential line at angle 45 degree. This is 45 degree. Then it hits this point. This is 0 degree. Radius is moving. And this is 45 degree. At 45 degree, this is the point. Tell me the equation of tangent line here. If I talk about equation of tangent line at 45 degree, then it will be y plus dy by dx into x. What is y dy by dx? Y equal to square root of a square minus x square in case of circular curve. Then dy by dx will be minus x by square root of a square minus x square. If that is the case, then what will be its value when angle is 45 degree? When angle is 45 degree, okay, what will be dy by dx? When angle is 45 degree, okay, at that time we have dy by dx is minus x by square root of a square minus x square. What is x at that time when it is 45 degree? When it is 45 degree, then tan up. When it is 45 degree, then this radius is, consider this radius is 1. Radius is 1. Then radius is always 1. Okay, if that is the case, then what is the base x? X is nothing but cos 45 degree. X is cos 45 degree. That is base by hypotenuse. Cos 45 degree is 1 by square root of 2. 1 by square root of cos 45 degree equal to base by hypotenuse. Hypotenuse is 1. Means x equal to cos 45 degree. That is 1 by square root of 2. Okay, then this point and sine, this height will be same at 45 degree. This point is 1 by a square root of 2, comma 1 by a square root of 2. What is the equation of tangent line here? If I talk in that fashion, then it is dy y equal to dy by dx into x, the equation of the tangent line there. What is dy by dx when x equal to 1 by a square root of 2? Dy by dx is minus x by a square root of a square minus x square. Just place x as 1 by a square root of 2. Whatever you get, that is the dy by dx. Whatever it comes. Okay. Y equal to whatever it comes into x. That is the equation of a straight line at that point. What is, how I can demonstrate that in a vector terminology? It is I plus dy by dxj. Because dy by dx is nothing but, it's a point. When on x axis it is 1, then how much it is on y? Then that is dy by dx. Then a point, a line that is passing through origin and another point that is 1 comma dy by dx. Okay, are you saying that any curve I can find the tangent vector as I plus dy by dxj? Certain. Okay. Now, if that is the case, then we have equation of tangent line. What is the equation of tangent? I plus dy by dxj. Now, someone can calculate dy by dx at x equal to 1 by 2, 1 by square root of 2. Then he can calculate the equation of tangent line. What we are getting now? Okay, now we have tangent vector. At any moment x comma y, what is the equation of tangent vector? That is the differentiation of position vector. Or it is I plus dy by dxj. If I have a vector and if I calculate the magnitude of the vector, Okay, then it gives the length. I believe it is all right. If I have origin and this is x-axis, I have a vector that is passing line 0 and x comma y. The vector equation is xi plus yj. What is the magnitude of the vector? Then it is square root of x square plus y square. If I have a vector that passing through origin and another point 1 comma dy by dx, then it will be I plus dy by dxj. What is the length of this vector? 1 square plus dy by dx whole square root. Hop, we got something. Means at any point x comma y, what is the equation of tangential vector? I plus dy by dxj. What is the length of that vector? 1 plus dy by dx whole square root. This is called momentarily length. At a point x comma y, this is called momentarily length. At that moment, what at every moment vector equation is different. Every moment. At any moment x comma y, the vector length is 1 plus dy by dx whole square root. Okay, that length corresponds to, if on x-axis I have a variation of 1. If someone remember it very well. If there is a variation of 1 along x-axis, then the length of the curve at that point is 1. If there is variation of 1 along the x-axis, at that moment the height is dy by dx. Okay, then the equation of that tangential line is y plus dy by dx into x. The equation of tangential vector is I plus dy by dxj. The length of the tangential vector is 1 square, I square, 1 square plus dy by dx whole square root. If there is a variation of 1, but the concept is it is now at every moment we have a vector. No need to go for any approximation. We did approximation in the first go, where we had a delta xi, is section, we went here, and then we calculated delta p. And delta p, if I calculate magnitude, it is a straight line magnitude, not the curve magnitude. Now we have another technology. This technology, tangent technology. With the tangent technology, at any point we have vector equation. Everywhere we have vector equation. At any point x comma y, that is generic x comma y, any x comma y. If I try to calculate the length of the vector means it will give the length along the curve. At that moment, then it is 1 square plus dy by dx whole square root. And that moment corresponds to 1 unit, not 1 meter. 1 unit on x-axis. If it is delta xi, then it is magnitude of I plus dy by dxj magnitude into delta xi. If 1 brings this much magnitude, then delta xi brings magnitude of the into delta xi. Now we will go back to our original solution. What is the solution of the n? If I have divided x-axis into n different parts, then for a particular part, this is ith section. Ith section length is delta xi. For that, if I go hit here, this length is momentarily length that belong to 1 unit here into delta xi. Summation I equal to 1 to n perimeter of the ith section. Perimeter of the ith section is now length of the tangent vector, that is length of I plus dy by dxj. That length belongs to 1 unit along x-axis. Now for into, we want for delta xi into delta xi. Now it will become now summation I equal to 1 to n 1 square plus dy by dx whole square root into delta xi. Okay. Now this is the solution. This is the solution for the full parameter, means from here to here. Okay, what it would be? It is impossible to calculate what it would be. How someone can calculate this? If n is very big, because we have divided into n different parts, n is big. Summation I equal to 1 to n and 1 plus dy by dx square root delta xi. I belongs to the ith section. Okay, now what about if n tends to infinity? Means we chop into very small section. Then how we can convert it to integral? So someone has to convert into integral calculus, and then he will get the solution. N tends to infinity, because this summation is difficult to calculate. If I turn n tends to infinity, then ready-made solution is available called integral calculus. Now we have now summation I equal to 1 to n, and first is function over x, that is the square root of 1 plus dy by dx whole square, because that will come dy by dx whole square will come as a function of x only. So altogether a square root of 1 plus dy by dx whole square can be considered as function over x into delta xi. This is nothing but area of a subsection where height is fx and width is delta xi. This is area of one strip I equal to 1 to n. If I add for all the strip, it will give the full area, and that area is nothing but fx dx. Makes sense? If I say I have x axis, if I say I have x axis, if I say I have x axis and this is the curve, at any point x here, xi, and any point xi, because if I chop x axis into n different parts, then at any time when we are in ith section, if we are in ith section, at that point, this is the beginning point of the ith section, this is the end point of the ith section. At the beginning point, height is fx at x equal to ith section, fx, and multiplied by delta xi, width of the ith section. This is the area of the rectangular area of this strip. Okay, now if I add for all I, then we are adding all the rectangular substrips. That is as good as full area of this curve between from here to here, where we have made n different sections. That is as good as if we have made n different sections from point x1 to x2, and then for each substrip we are calculating the area and adding it. One strip's area is fxi into delta xi, and now we are varying I. Summation I equal to 1 to n. Summation is sigma sign. Summation I equal to 1 to n, and then fxi into delta xi, fxi into this substrip. Then I adding for all I. We are more or less we are calculating the full area between x1 and x2. There is a better way to write this. That is integration x1 to x2 fx dx. Now, what is fx? Fx is the square root of 1 by dy by dx whole square. Someone can compute it. And then dx, and then first differentiation, square plus 1 square root, that will come as fx. Then dx integration, and then from x1 to x2. Certainly he will get the area of the semicircle from here to here, then multiply by 2. What is next that we will talk? Dy by d, the vector what we are getting, the someone will intercept here. Certainly. What is your position vector? Tell me. Position vector is measurement of, there is something called unit. What is the unit of length? Then it is meter. What is the unit of length? Then it is meter. What is unit of differentiation? Then it is not meter. It is by what you are differentiating. If unit of length is meter, then if I differentiate this meter with the time, then the unit will not be the meter. Dy by dt will be velocity, meter per second. If I do differentiation, again the unit, with each differentiation unit changes. With each integration unit changes. If fx is velocity, and if I do fx dx, or ft is velocity, or fx is velocity where x is time, consider x is time. This x-axis is time axis. If person is moving along the time, then his distance is growing like this. First he started from a position. This is the beginning position, and then he is growing in the time, and then his position is growing like this. Then he is coming back to the origin. Then he is coming back to the zero. Okay, and then he is walking in reverse direction and coming back to zero again. Means this is something interpretation someone can understand. Now anyone would intercept here. What is P? P is displacement vector. If this is x-axis and this is the curvature, then curvature is the displacement we want to calculate. If this is position vector, if this is position vector, then position vector correspond to displacement, right? Yeah. Because if this is P1, this is P2. P2 minus P1 gives the displacement, that is delta P. Delta P is the correspond to displacement, right? Yeah, it is correspond to displacement. Then how delta P by dx, dP by dx you are talking, right? That is a tangent vector. You are doing all mathematics on dP by dx. Then dP by dx is not the displacement vector. It is velocity vector. Then how you can compute through velocity vector? You are doing dp by dx, understandable. Dp by dx means if it is x is 1, then how much change in p? That is the momentarily tangent you are saying, dp by dx. P is xi plus yj, dp by dx is I plus dy by dxj, but both are not same. If one has a unit of meter, then another has unit of meter per second if x-axis is time. If delta P is meter, then dp by dx is certainly not meter. If you consider x as time, then this is a velocity vector. Differentiation of displacement vector will be velocity vector. How you are computing through velocity vector? It is different thing. Okay, then how you get the displacement through velocity vector? Okay, we will see how it is. We will draw one more graph now. Okay, to understand in more better concept, because these are the pillar stone of the going for the very deep and complex calculation. If someone understands these concepts, then everything is cakewalk only. If this is x-axis and this is considered the function over x, that is function over x, and that is the magnitude of dp by dx, that is I plus dy by dxj, its magnitude, that is fx. I was saying, consider this is fx and this is dx. What is that? Okay, probably we will take one more session in that, and that we will calculate. It is too long now. Okay, that we will see. These explanations are certainly not available in any of the book. Please don't mind supporting us or mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number. We will talk about velocity vector, acceleration vector, and then their relationship with the displacement area vector and those kind of things.